And I'm very happy to see a pretty full room here. This is it's an exciting topic. So after 2.5 days of very spacey stuff, we're taking it a little bit closer to Earth with HAPS. I'm toying with the idea of doing a Q&A session where I walk around with the mic and just, if you have a question, raise your hand. I don't particularly like Slido, with all due respect. So we'll see how we go with that. But in the meantime, got a handful of questions here in my handy notebook and have 4 excellent panelists joining me here. So we have Jeremy Yin, better known as JJ, Director of Business Development for Alifecom. We have Sunao Toya-san, Director of Aviation Engineering, Space RAN Business at Space Compass. We have Keith Wu, the Director, Research and Planning Division of Telecom Technology Center. Well played to stand up and bow. That was on point. And then Su-Wei Chang, Founder and President of TMYTEK. So before turning it over to the panelists for a short introduction of each of their companies and what they're doing in the HAPS domain, just a very short, non-technical, I'm not a HAPS expert, summary of HAPS, better known as High Altitude Platform Systems. So this refers to things like blimps, certain types of drones, balloons, etc., can be used for communication, can be used for certain types of remote sensing, and again, closer to Earth. Toya-san was saying earlier, like 18 to 25, 30 kilometers that you guys are looking at, so higher than an airplane, but much lower than even the very lowest of VLEO satellites. So with no further ado, I will turn it over to JJ for his introduction, and then we can just go down the line. So maybe a 1 minute to 1.5 minute intro of your company and maybe some exciting developments that you'd like to share from the last year or so. So, JJ?
Hello, good everyone. I'm Jeremy. You can call me JJ. Easy to remember and easy to pronunciation. Okay, our company, Alifecom, we build a GNOB design from terrestrial. Now we go to NTN, non-terrestrial network. So now we work with the other partner, and we found there is a different opportunity from terrestrial, because now everybody will use terrestrial network, and now we next stage will be non-terrestrial. Why we go to non-terrestrial? I think it's quite, we're talking about this 2 days about why we should go to non-terrestrial, because we see the potential. And you can see not only the 4G, 5G, and 6G, even later the vision, we can see more and more application will go to non-terrestrial because the wider coverage and also different application. So I think we also see there's some technical limitation and the difficulties. So today we are going to discuss about HAPS, because this one we can compensate some limitation about the satellite, and also we can compensate the terrestrial network limitation. Okay, so our company, we build the GNOB, the FPGA design, and this one can do the different payload for different vehicle, including the terrestrial and the non-terrestrial. So later we are going to have a more detailed discussion about HAPS. So what we can do and what limitation about regulation, and in the future about business, how to turn from research to the real business term. Okay, thank you.
And just a small point to dwell on, I like the way that you described at the beginning, sort of expanding opportunities beyond terrestrial. So really coming from more of a terrestrial looking up rather than a space looking down. So it feels like maybe there's a bit more of a kind of terrestrial telco-y kind of feel to some of these HAPS technologies rather than a very space, but coming down into like airspace kind of a feel. So something we can talk about later, but in the meantime, Toya-san, would you like to give us an intro of Space Compass?
Hi, I'm Toya. Sorry, I'm Toya from Space Compass. And Space Compass is joint venture company invested by NTT, which is the biggest telco in Japan, and also the Sky Perfect JSAT Corporation, who is the biggest geo operators in Asia. And it was established in 2022. And now Space Compass is preparing for the commercial service commencement in 2026 using HAPS service. And this 1 year, we had a lot of activities related to the rule making in Japan, related to radio law with the Japan MIC, and also we had some POCs with Aluto, which Space Compass invested last year. Yeah, so I'm looking forward to discussing and introducing such kind of topics today. Thank you.
Excellent. Thank you very much. Keith?
Okay. Hello, everyone. Good afternoon, everyone. I'm Keith Su from Telecom Technology Center, and our organization helps the government, Taiwan government, to research the HAPS verification POC last year, and we use the Boolean type to make sure to validation the communication model, and we also try to validation the air vehicle, just like the Boolean. And we still ongoing to want to make sure do some research in the future. We try to use a drone or maybe the fixed wing in the future, and we try to help the we use the research the hubs, and because we want to help our government to enhance the network resiliency. And so we're still ongoing doing some research program, and I'd like to share some our research experience to you all. Thank you.
Thank you. And Su-Wei from TMYTEK.
Yes, thank you. So hi everyone, I'm Su-Wei Chang, founder and president of TMYTEK. So TMYTEK, we are a company who focus on the millimeter wave related technology, especially for phased array system. So we also debut our company on Taiwan exchange market this year. So I think this time our phased array actually has been designed in for like a terrestrial network, like 5G, 6G. Also, this time we demonstrate our multi-orbit use terminal with our partner, Comtech. And also, why I'm on this stage is because we also work with Space Complex for the HAPS. So we actually this year we delivered the gateway, and we are working toward the payload system right now. So I'm really like looking forward for the discussion. Thank you.
Well, thank you, and really happy that we have several different players from totally different parts of the value chain working together, doing R&D. I mean, it's a fun and collaborative panel, so hopefully no fights break out up here. So maybe digging a little bit more into the real world use cases for HAPS. I was speaking earlier with Toya-san, and he was telling me, remote sensing is one which being a Philistine, I hadn't even thought about that. I was thinking HAPS are mostly for communication. So maybe talk a little bit about what do you see as the near term, like next 2 or 3 year use cases for HAPS, and if you want to put kind of a twist on that, what are some of the technologies or solutions that you and your company are developing to enable those use cases? So whomever would like to go first, there's no rules here, so.
Yeah, and I believe that one of the most important and real use case would be disaster response and disaster recovery in Japan, because there are so many big earthquake, and for example, Nankai Trough earthquake, which will be around magnitude 8 to 9. Has been periodically happening in every 100 years or 150 years, and according to the earthquake analyst, it will happen. So such kind of case has to be expected and prepared well. And when we have such kind of disasters, of course, old buildings collapse and sometimes tsunami hits the areas. And in such case, mobile base station becomes unusable because of the power outage and terrestrial link outage. So in such case, this direct smartphone connection to HAPS would be one of the important law to support the security activities and rescue activities and also other activities. And in addition to the direct smartphone connection, as Brian-san mentioned, sensing would be also important because HAPS has unique sensing solution because that HAPS can loitering in the fixed point, which means that HAPS can get the video, not photo. Yeah, that would be main differentiated point from satellite sensing. Yeah, so I believe that such kind of disaster recovery and disaster response would be the one realistic near-term solution expected. Yeah, and also demanded in Japan.
Thank you.
Okay, about the next 2 years, and we can have a clear picture about HAPS is a regional application, not satellite. Satellite is global. Okay, I think that you're expert. You know how many satellite LEO can cover the world. You need more than 150. That's a minimum to cover all worldwide. So how many HAPS can cover your country? I don't know your country how big it is, but we can make example in Taiwan. You just need 7. 7 HAPS can cover. And the HAPS is a regional. I mean, it is a regional capability, is not global. So HAPS will adopt by the countryside, not the it's driven is by government. It's not driven by the commercial side because it's for the domestic area. The reason is because the altitude. The altitude about the HAPS we are talking about is like 80 kilometer to the above. So in the regulation, aviation, ICAO and FAA regulation is under 80 kilometer. So it means under 8 kilometer is by civilization, aviation control. How about above? Sorry, above now is controlled by your government military of defense. So in this kind of operation will be domestic application. So just a response about Toyo-san, he mentioned about the disaster. Again, now the Taiwan we are the same, we have many disasters. So Japan earthquake, we do have, and our earthquake is more stronger. And also we have typhoon, we have many disasters, non-disaster, and also we have a big threat. Okay, so not a political, but we have big threat. So it means for the defense communication system, how about communication resilience will be the issue as well. So HAPS can totally cover for this kind of application. So as part of point of view of our company, we can see in the next 3 years, not like a GEO, LEO, MEO will be commercialized, but for HAPS, there will be about defense. I mean, the government defense will be the first approach adopt because the easy to adopt, easy to approach, and also the cheaper and also easy to maintenance. And about expense, it's much lower compared to the satellite.
Okay, so I think I just want to add some point. So we see HAPS is, I would say, less piece of the puzzle for the communication network. And so, because you can see HAPS has the like a service link can connect to the cell phone, and it also has the resilient advantage, because it has another two payload. One is the satellite-based payload, which means it can connect to all the different satellites, and also it has the feeder link to the ground side. So that means it's like a very good platform for the NTN, the non-terrestrial network. So, and also I think HAPS, because we operate the drone, so it has the mobility and it can be rapid deployment. So I think this is very important, especially if you want some area when some things happen, you want some area can really have the communication coverage and to, support not just, some like a backhaul. It's also for the users. So I think that's a very good solution. So we will see this technology as a complementary solution to other solution together. So right now, of course, I think for the government use and for all the disasters is the first step. But we believe for like because of its advantage, it can really use for other, maybe some consumer coverage as air base station. So that's what we see this technology can provide. Yeah.
Yes, I can add some point. Mr. So-Young and Mr. JJ and Su-Wei already talking about many features. And in our experience, because there are some kind of the situations like the weather and wind speed is too fast, and sometimes or the power is interrupted. And when in these situations, the HAPS may be a good tools to provide continuous communication. And it also can use to provide communication on the many, this morning, we're talking about the mountain time communications. It might be some kind of application in the future HAPS can use in that area. Yes, this why I can add some point here.
Okay, and we've touched on this a little bit already, but one of the questions I sent out before the panel, and I understand we're in a room full of satellite people who are now sharpening their knives, but how is HAPS competing with GEO and LEO versus collaborating with GEO and LEO, and maybe expanding on a point that Toya-san brought up about direct-to-device? I'm not a technology person. I use a smartphone, and that's about as much as I understand it. What are some of the, looking at the technological challenges of satellite-enabled direct-to-device, how do those challenges compare if we're talking about HAPS systems as opposed to SATCOM systems? So broad question, competition versus collaboration, and then maybe more specific sub-question from some of the more technical folks on this panel, satellite direct-to-device versus HAPS direct-to-device.
Yeah, and as JJ have mentioned, firstly, HAPS, geosatellite, and LEO satellite, each has its own advantage and disadvantage. It's clear. And one of the most important point and complicated point is that such advantage and disadvantage sometimes get weakened and strengthened depending on the country area size and also country location of usage. Yeah. This is one important point. And yeah, I believe that HAPS and geosatellite and LEO satellite complement each other. And one of the biggest advantage of the HAPS would be the distance of the short range because of the lower altitude. And of course, yeah, we are aware of the recent movement of the satellite solution of direct smartphone. Yeah. And because of the distance, I guess that there would be some bottleneck of the throughput, especially for uplink, because user equipment, I mean smartphone, is specified, specification is defined by 3GPP. So we cannot add bigger amplifier in the smartphone. Yeah. So because of the limitation of the smartphone EIRP, uplink throughput would be relatively smaller than HAPS. I mean, if we use LEO, yeah, and if we use HAPS, we can easily expect megabps or upper 10 megabps connection, including uplink. And if we use more sophisticated technology, such as a MIMO, using the different both polarization, which has been already used on the terrestrial mobile network, we can get higher throughput. So, yeah, I think the better throughput would be one advantage when we use HAPS in terms of the direct smartphone connection.
And especially on the uplink, that's an interesting point. So, anyone else?
Okay, About satellite HAPS, there's a different definition. Is the satellite is for global operation. HAPS is a regional. So what I mentioned in the HAPS and the satellite will be cooperation. They will compete. And about the technical part, we can see that currently your phone, people talk about how about satellite directed phone. So I want, based on this topic, to have discussion. Currently your phone, no matter what brand you have, now or your chipset, and they follow 3GP, LTE and 5G, they can reach to 100 kilometer. I mean, your traditional network, they can reach to 100 kilometer, but reality, they can reach to the 35 kilometer. So you can see that HAPS is running at 20 kilometer away. So your current chipset can fulfill requirement for that. Because the TA, Thai Advanced, this the limitation and the range go to the link with the ENOB and GNOB. So the HAPS application, 20 kilometer, just can meet now traditional network. It means probably your mobile phone still have a chance with no any modification, you can link with HAPS. But for the satellite, it's not possible. So now the people are using the last way they do like a Doppler conversation. They want to use like ERP, the high ERP, high antenna gain, and about the checking the satellite way to do the mobile phone direct to satellite. You know, you need a new design. But if we're talking about HAPS, yes, just your mobile phone can reach this happen, but I mean, it still have some difficulty because 20 kilometer is original design for terrestrial. Now we are talking about in space. So line of sight 20 kilometers is not found, but reality, your mobile phone still have a modification your front-end design, antenna design. But just modify that one, you can reach to HAPS. You don't need to change a lot of things. You don't need a big antenna to do that. So the HAPS is easy for all now the current all the mobile phone manufacturer can easy to reach, not to the satellite. Satellite you need the more advanced design for that, but for HAPS easy to do it because the range and now the 3GP the regulation sorry not the regulation by 3GP protocol, they can reach to the less than 100 kilometer. So I mean for the HAPS 20 kilometer easy to reach, and also latency is faster, and you can have a great throughput and a bandwidth and the moderation scheme. I mean, that's all physical limitation HAPS can easy to reach. Again, HAPS running for is a domestic area approach, and the satellite is for global. So I mean, there's two different ways. So you can see that one is for different application, and also we can depends on different application, and we can have a different design for that.
Thank you very much.
Thank you. So I think, as I mentioned in the first questions, we think HAPS is a complementary network with other networks. First, I mean, it makes the entire networks more resilient because you have more connection ways, right, to go into the network. And I think Toya-san and JJ also mentioned about it's more regional. So which means you actually have fully control. So nowadays, if you want to use the satellite to do direct communication, it might still have some limitation. But it's regional, so for example, if we want to use in Taiwan or in Japan, actually the government can have free control. You just fly your drone up to the sky, and then you can start do the communication. So of course, the coverage is less, but means more controllable. And also the link budget, like Toya-san mentioned. So if you want to do some like a higher throughput transmission, so it can do that. I think for the communication wise, we care about the efficiency for the energy use, right? We care about the price, like bits per joule, so that converts to the price. So I think the link budget, why link budget is so important is because of that. So this is some point I want to add on. So we still think it's like a complementary, not direct competing. Yeah.
Yeah. I also think it's a complementary with the satellite. We know satellite is very important, and because it can provide high-speed broadband, and but I think Mr. Su-Wei already talked what I want to say, because the fully control is important, especially in Taiwan. So we maybe HAPS is a key point. If we want to go into we build a whole ecosystem and cooperate with the international. It's important for us.
Thank you, and I will now turn it over to the audience. I will hand deliver you the microphone. We have Terry in the front, and everyone else, get your thinking caps on. I'd like to get my step count up a little bit, so.
Thanks, Blaine. I'm a satellite guy, but I'm a big believer in HAPS. I think the panel's made some really, I'm going to just make a few statements and I'll ask a question. But I think, you know, we've heard about sovereignty at this conference, and a lot of countries are talking about LEO systems for sovereignty, but it doesn't make a lot of sense because the largest countries are only 2% of the Earth's mass area, and 98% of the time that network is not over their country. So sovereignty of a LEO system is very, very challenging, or it's a waste of capacity if you can't sell it anywhere else. And I think the point about regionalization is a really good point, because having a sovereign system based around a HAPS technology could be really good. I think I don't believe in the stories that are being told and direct-to-device being able to do broadband from LEO at 500 kilometers. The link budget will allow you to do text messaging and low bandwidth applications, but to get to be able to do true broadband, you need to be a lot closer to Earth. Base stations are traditionally to work to 10 kilometers. At 20 kilometers, the challenge is a lot less than 500 kilometers. So doing broadband from the stratosphere makes a lot more sense. There's a company called Stratospheric Systems in the UK who are doing some really interesting stuff with HAPS. They've got their antenna, which is a virtualized antenna, which is equivalent to 400 base stations in the sky, right? They're also using hydrogen as their fuel, and the reason they're doing that is most HAPS today are using solar power. There's battery limitations, and the weight you've got to carry means the payload on the traditional HAPS is very, very, very limited. Whereas with the stratospheric system, you can carry quite a lot of payload, which enables you to provide more connectivity from the sky. Deutsche Telekom invested in stratospheric systems for a really interesting reason, because with 5G and 6G, you have densification because the radio wave length is a lot shorter. So you need more base stations. And their biggest cost in Germany was rental of roof space for putting antenna. So their business case was, we don't have to rent so much roof space to put new base stations because we can put it in the sky. And that was their logic for investing in stratospheric systems. SoftBank's been doing a lot in Japan as Space Compass, but SoftBank did a turnaround recently where they were developing a HAPS similar to the Altos ones that Space Compass are looking at, and they're working with a company out of New Mexico called Sky, which is more like a Zeppelin service, and they're looking, I think they're trialing at the moment, looking to launch early 2026. So my question is, how does Space Compass see SoftBank in the market? And what do other people think about Stratospheric system, which is a little bit further in the distance, but is using some different technologies?
5 panelists for the price of 4. Thank you, Terry. But that was interesting. Thank you.
Okay, yeah, thank you very much for the question. And yes, recently in Japan, HAPS competition is very active, and SoftBank is trying to use airship type Sky, that is totally different from fixed wing type Zephyr, Alto. And actually, I also understand that each type of the HAPS has its advantage and disadvantage. And fixed wing type advantage would be the station keeping ability which against the westerly wind. And as you might know, in East Asian, northern area, in the stratosphere, westerly wind is very strong. And in order to keep the fixed point loitering, we believe that fixed wing type would be a good solution, yeah, in order to, for example, provide with the reliable connection and also sensing service, because sensing service is strongly related to the aircraft position. Yeah. On the other hand, also I understand that airship type HAPS has its advantage, and main point would be the more mass and consumption power for the payload. Yeah. So, how to say? We don't deny SoftBank approach, and also Space Compass is not going to stick to only fixed wind type. Yes. So, Space Compass has the vision to be the operator of HAPS, which means that, of course, we use Zephyr by Alto, and also we are looking at other options, including the airship type and maybe balloon type. Yeah. So, yeah, including such kind of each advantage and disadvantage, we are going to allocate and assign appropriate platform to each use case. Yeah, this is our understanding and approach.
Anything else to add? Feels good to be on this side, but okay. Any other questions from the audience? Questions, comments, going once, going twice. I guess I got to sing a song. No, I got a couple more questions. Well, thank you, Terry, for that question, and that was some interesting quip about Deutsche Telekom's biggest expense being roof space. I didn't know that, so for that HAPS project. Yes. Oh. I do want to get, well.
All right, never mind. Hi, Greg Daffner. Good afternoon. Question, have you guys thought about a different sort of architecture under certain circumstances, instead of going up and down from the ground to your customers and maybe to your gateways, in certain more challenged geographic environments, perhaps going from the ground for your customers to your platforms, your HAPS platforms, and then relaying from the HAPS platform to a LEO, and then maybe inter-satellite links back to a gateway. I know someone's doing it. Have you taken a look at that and seen certain virtues under certain geographic circumstances, please?
Thank you very much for the question. And yes, that is a good option. And basically, HAPS platform expect feeder link to connect with gateways and service link to connect with UEs. However, we also understand the benefit of the approach using the satellite backhaul. I mean the ground, LEO satellite or geosatellite to HAPS, then UE. Because if we achieve this topology, we can free the location lock from gateway. So that is a very good point. And also, we are doing the development using the opportunity of NICT, which is the technological governmental entities. Yeah, we are using that budget. And in order to achieve that architecture, one of the important points is regenerative payload, which means that payload must have the base station. And recently, the base station chip development is quite active and improving a lot. So basically, on the terrestrial link base station has very big equipment. However, it's possible to make it smaller into chip as a SOC. So, and on the other hand, we are looking at the very good movement of the LEO operators such as Starlink Mini, very small terminal, or Kuiper, Ka-band, very small terminal. Such kind of collaboration would contribute to the achievement of the topology you mentioned. Yeah.
Okay. So I think I just want to follow with Toya-san, because actually we are making those payload and the gateway. So actually, I think the very challenging part is, for example, now the Zyber, it can operate with all the payload system with the like a battery and the solar panel. It's like more than 40 days. And it's very challenging because the weight and also the power are limited. So I think for the original structure, I mean architecture, is already have this satellite backhaul. So that's for resilient purpose, right? So if your gateway is not working, then you can still, through the satellite, I mean, your connection can go outside. But right now, well, we cannot talk too much about the detail, but when we discuss with our partner, how to define, for example, the payload, for example, you need to fulfill the link budget while maintain the low power consumption and the weight. And also this, because the environment, for example, is around minus 50 degrees Celsius. So how your payload can survive during this environment is also very challenging. But the basic idea is, yes, we want different ways to get into the network. And there's one more thing I want to mention is about the spectrum, right? So, for example, for the feed link, actually is quite follow with the 3GPP. So we leverage the millimeter wave spectrum, the frequency, for the backhaul, the feed link. And then for the satellite payload, we still follow with like right now more popular is KU band, and maybe future Ka band. It depends what is the throughput you want to achieve. So I think that is something from technical view we can add it about how to achieve that goal. Yeah.
Yeah. Thanks for your question. In fact, in the first year we demonstrate from HAPS to the ground, but in the future we try to make add-on from HAPS to the satellite. That's our, but it's not. It is the future. Maybe the third year, but not. We still not demonstrate the HAPS to the ground now. So, and I think you also mentioned about the one key point is because it's the multi-layer communication. So I think this is maybe in the future, and we can demonstrate in the 6G environment. That's multi-layer communication world. Thank you.
So we're down to about 2 minutes, and there is one question from Slido, and I would like to address that just very quickly. And I'm going to partially answer it, and then I'm going to put a spin on it, and then I'm going to give you guys the chance to do a one-word answer. So aren't HAPS vulnerable in the case of military conflict? I think the answer is almost certainly yes. I would compare this to what we've seen in Ukraine, for example. You keep hearing that it's a war being fought with drones, and if you have a $300 million fighter jet versus a $3,000 drone, there's obviously, the fighter jet has its purposes, the drone has its purposes, but undeniably the drones are cheaper and easier to build, easier to deploy, and so on. And so is it a fair characterization, and this gets to the agree, disagree, one-word response, to say that maybe geo satellites are a bit like a fighter jet, and HAPS are a bit more like a drone in the event of a conflict? So, agree, disagree that that's a reasonable characterization?
Yes. Firstly, okay. When we operate, for example, satellite, we have ephemeris, which means that satellite have its own altitude, inclination. Yeah. So, if we have very big missile, yeah, maybe it would be easier to point to the satellite. And yes, as you mentioned, yeah, if the drone flying over very low altitude, it would be vulnerable. Yeah, the enemy can attack the drone. Yeah, and one thing we can, I might say, is that the HAPS fly over 20 kilometers. So compared to the drone flying closer to ground, it would be relatively difficult to point. And also, HAPS doesn't have ephemeris data like a satellite, so enemy cannot easily detect next time which direction is moving or something like that. So
less predictable,
yeah,
yeah.
maybe we need to consider about that. Yeah.
Okay. Anything else?
The HAPS R2 is pretty high, so it means we use the money to calculation. Do you know how much money you can shut down the HAPS? I can tell you, it's more than the HAPS. The missile cost is more than HAPS. So okay, that's the one by one that change. So still earn, you still make money on this. I am not mean you just make HAPS to make money. I mean just make in the war field. HAPS is not easy to take off.
Yeah, because HAPS is operate in 20 kilometers around the ground, and so it's higher than the aircraft because aircraft is 10 kilometers. And so if you want to, I think it's valuable in the military conflict because HAPS can use to gather many information, and this I think in the world military used this information is important because it can help the government or the military to make the right decision. Thank you.
And Su-Wei, you guys are paying for lunch, and so you get the last word.
Thank you. So yeah, actually, I think they already mentioned most of the point. But actually, I think normally if we talk about a drone, then we want to do the anti-drone. So you want to use a jammer, right? Or you want to use like the gun to shut it down. But because HAPS is really high, so I think jammer is, if you want to use so big energy to jam in, I think it's very, very difficult. So the only way you probably want to use the missile to shut it down, but as JJ mentioned, probably I think the missile is much more expensive than the HAPS. So you don't want to do that because normally you want to use the missile to shoot something more expensive, that's more valuable. So and it's it's on the 20-kilometer high, so and it's not so big. So I would say even you want to shut it down, it's still not that easy. So that's I think for this some summarize of the bullet points. Thank you.
Excellent. Well, we squeezed a lot into 40 minutes, so if we could have a big round of applause for my panelists, JJ Toya-san, Keith, Su-Wei, and Terry. Thank you very much to all of you, and back to Andy.